Hello everyone, let's talk about lecture 4. So in this lecture, we talk about polynomial expressions, how to factor expressions, and how to expand them. For polynomial expressions, the polynomial expression is of the form a sub n times x to the power n plus a sub n minus 1 times x to negative 1, and so on, plus a2 times x squared plus a1 times x plus a sub 0. So in this case, a sub n minus 1 is 2, a1, a0 is called the coefficients or constant coefficients. A sub n different from 0 is called the leading coefficients. A sub n times x to the power n is the leading term. N is the degree. So n will determine the degree of the polynomial. So if you have, for example, a x squared plus bx plus c, this is the polynomial of degree 2. A sub 0 is constant term. X, of course, is the variable. And another concept that we talk about in class is the like terms. Have same variable with the same exponent. The two techniques that we use to combine algebraic expressions or polynomial expressions are expanding and factorizing. So for expanding, this is the process of removing brackets or parentheses, or this is the process of changing an expression from a product of factor to a sum or difference of terms. So for example, if you have x minus 1 times x plus 2, this is the process of removing brackets or parentheses or changing this expression from a product of factor, so here the product of factor, to a sum or difference of terms. So what you can do is you can use FOIL or distribute number term by terms. So that means I'm going to take x and distribute to the next parentheses. So I get x squared minus 2x, and I take negative 1, multiply with x, I have negative x, and negative 1 times negative 2, you have positive 2. Next, you're going to combine like terms. That is x squared minus 3x plus 2. So this is the expansions process. So another concept is factoring. This is the reverse process of expanding. This is the process of changing a sum or difference of terms to a product of factor. For factoring, you can use special product formula. You can find common factor, or you can factor x squared plus bx plus c. For this method, we're looking for two numbers a and b such that when they add together, they have capital B, and when they multiply together, you get capital C. You can rewrite x squared plus capital Bx plus capital C as x plus A times x plus B. So let's do some example on that. So I want to factor x squared plus 5x plus 6. So what I'm looking for two numbers a and b such that when we add together, you get positive 5, and when they multiply together, you get positive 6. And the two numbers are 2 and 3. So you can write x plus 2 times x plus 3 because 2 plus 3 equal to 5 and 2 times 3 equal to 6. In the next example, I want to factor the polynomial of degree 2, that is x squared minus 3x minus 10. What I want to do is I want to look for two numbers a and b such that when they add together, I have minus 3, and when they multiply together, I have negative 10. So the two numbers that I can think of is negative 5 and 2. So I can factor this, so x minus 5 times x plus 2, because when they add together, they have minus 3, and when they multiply together, they have negative 10. Another example that we did in class using the special product formula is x to the 4th minus 9x squared. So the first step is that you have to identify the common factor. So in this case, x squared is the common factor. You take x squared out, and you're left with x squared in the first term, and minus 9. For x squared minus 9, I can use a squared minus b squared. This is the difference of 2 squared. This is equal to a minus b times a plus b. So that means the value of a and the value of b matters. In this case, capital A is equal to x and capital B is equal to 3. So you write x minus 3 times x plus 3. So consider the next example, x minus x cubed. I want to factor this polynomial expressions. The first thing I notice that x is the common factor, so I write x and I left with 1 minus x squared. So once again, I can use the difference of 2 squared, a squared minus b squared equal to a minus b times a plus b. As I mentioned, the value of capital A and the value of capital B matters. In this case, capital A is equal to 1 and capital B is equal to x. So the final result is x times 1 minus x times 1 plus x. I hope this video helps. Please let me know if you have any questions.